Today we are supposed to discuss the start with the forced regression and what are the different intricacies of the forced regression, what are the products of forced regression, and how they are formed in different kinds of setting. That is the first goal, which is today. So we will be starting with the forced regression. Now, what is forced regression? Forced regression is the product of the simple product base level form. Sediment supply. Whether sediment supply is low, sediment supply is high, I am not bothered about. My primary thing here is that forced regression is basically because of base level form. Now, so what will be, so in a card, how I basically represent the forced regression? The forced regression starts here when the base level starts falling. And it goes up to here, which I call the correlative conformity. Correlative conformity till that the base level continues. And that is what I call the CC. So what will be at its base? It will be basal surface of forced regression. That will be at its base, and I will be getting the RSME, that is regressive surface. We will come to this. What are the meaning? What is the difference between BSFR and RSME? That will also come. We will discuss. Both are not same, but it will be the product of forced regression that will be overlying the BSFR and RSME. Now, what is we will discuss today? We will discuss today now by giving examples. What is the fundamental difference between BSFR and RSME? And then it is taught by the correlative conformity. So that this portion is what we call the forced regression. Now, there, as I discussed the normal regression, with two different kinds of setting. In one kind of setting, which is actually the wave dominated shoreline, where no river system is coming. So I am totally dividing the shoreline. Wherever I am discussing the normal regression, I am discussing the forced regression. I am dividing the shoreline into two different types. One is a wave dominated shoreline, which is low gradient, and another is the river dominated shoreline. Which is high grade. Okay. Now, first we will start with what will happen when it is a wave dominated shoreline. What will happen when it is a wave dominated shoreline? Have you drawn it?
Yes, sir.
Have you drawn it?
Yes, sir.
Okay. So this is what I am discussing about the wave dominated shoreline, which is a low gradient shoreline. And as I discussed in case of normal regression also, that we are actually getting 0.1 to 0.3 degree. That is the general gradient of the shore face. 0.1 to 0.3 degree. That is the general gradient. I discussed it in the normal regression also. Now, what is actually happening? That the sea level is continuously falling. Sea level is continuously falling, and your stratal stacking that is taking a pattern like this. So what I call it? I call it an opulent. I call it a opulent. That means each strata, each younger strata, it is leaving the earlier strata exposed and not covering the strata, because continuously the accommodation space is decreasing. So from with respect to 1, the 2, the accommodation space is more or less, 3 more or less, 4 more or less. So accommodation space is continuously decreasing. So the younger strata cannot cover up the older strata. So it will be only prograding, it will not be aggrading or covering the older strata. We call it opulent. Now this is number 1. And what is happening, because the sea level is falling, the entire region, these, they are all subaerially exposed now. They are all subaerially, because the sea level is now here. So everything above it is subaerially exposed. And that subaerially exposed, this will be marked by, this is an unconformity. And how I will be identifying this unconformity? There will be bypass, channel incision, incision, or we call it channel erosion. Wind erosion, enogenesis, all these there will be the signature at the top, because it is a unconformity surface and base level is continuously falling and thereby exposing this area which was earlier underwater, which that is now getting exposed. Now this is number 1. What is also happening here? What is happening here is that every time the sea level is falling, that the prevailing wave regime, it will try to equilibrate and make the equilibrium wave profile, which I discussed during calculation as well. It is the same story here also. When the sea level is rising also, sea level is falling also. So when the sea level is falling, again you are basically changing, because if this is the equilibrium profile, now and then you have a fall, and that becomes it. So it will make this gradient again the same gradient to this, so that it further goes down. So with respect to this profile goes down, and thereby it erodes this. Am I clear? Am I clear what I am saying?
Yes, sir.
goes down and it further cuts here. So this red line that is further, actually it is marking the wave erosion surface as it will go down. So what will happen, that if this is the, suppose this is the time when the sea level starts falling. Sea level starts falling. So what will be this portion of the contact? It will not be a erosional contact. There is no erosional contact because there is no erosion. Erosion will be only in this part because this is subaqueous and there is no erosional agent there. But the erosion is coming here. As the wave is trying to maintain the wave equilibrium profile, the erosion is coming here. So how I then define this erosion, what is coming here, coming here. So this becomes erosional surface. This becomes erosional surface. This erosional surface I call it RSME. That is regressive surface of marine erosion. Regressive surface of, and what is this surface? This is the BSFR. BSFR, which is the first surface which marks the fall of base level. So this is the first surface which marks the onset of the fall of base level. And during the course of base level, the subaqueous erosion that is happening to maintain the wave equilibrium profile here, that actually is making the RSM. So what will be BSFR? BSFR, it will be a conformable surface. Conformable surface. What will be RSME? RSME will be a erosional surface. Is it clear?
Yes, sir.
So we must understand that these terms, they are not interchangeable. They are not interchangeable. Every term has a meaning, and the process wise it has a meaning which needs to be understood. Now you see maybe it is clear. Those who have not got it clear, please get it clear right now. It may not be clear to everybody.
So the erosional surface that is forming RSME, is it in the intertidal zone or subtidal zone?
No. Oh, okay, I am coming. So this RSME, it will be basically forming in the lower intertidal to subtidal zone. Lower intertidal to subtidal zone. So basically your intertidal material that will be coming to the subtidal. So mostly it is formed at the base of the shore face. So actually what is this surface? This is the base of the shore face. So shore face that will be actually coming onto the shell. So sometimes it is the shore face coming onto the offshore shell, or the shore face plus inner shell together that come into the offshore shell of the distal shell. I'll discuss it. I'll discuss with log what happens. What is the difference? I'll discuss.
Okay.
Now this is what you get when you have a wave dominated shallow gradient shoreline. Then you are getting this formation of BSFR and RSME. So that is it. And so what is the force regressive product here? This is actually the force regressive product. This is the and this is the force regressive product. And so what is the basal surface of the force regressive product? Either BSFR or RSME. Well, I will come separately discuss the character of BSFR and RSME. That is different. Now, what will happen? So this regression, suppose this regression that stops here, fine. So this surface, this regression stops here. So this is the last force regressive surface. After this, the sea level is slowly started rising. So what is this surface I will call? this surface, what is this surface I will call? This is the correlative contour. Is it clear? What is correlative contour? This is the last surface. This is where you have the correlative contour. Fine. So correlative conformity I will be basically identifying at the deep marine setting. At the marine setting, in the subtidal condition, you have the correlation. But there is the identification is not very easy. We'll discuss that how really we identify that and how we designate that. But theoretically, I am saying theoretically that the fall starts at BSFR, and in the process of fall, the RSME is generated. Above the BSFR and RSME, the post-regressive product will lie, and the topmost surface of the post-regressive surface is what we refer to as the correlative surface. So, what is this correlative conformity? This unconformity, what is forming here? This unconformity, what is forming here? This becomes the correlative conformity at the deeper point. So, if you remember the definition of sequence stratigraphy, what is the depositional sequence? The genetically related package bounded between unconformities and their correlative conformities. So, how the unconformity and their correlative conformity is formed? So, unconformity at step 1, 2, 3, 4, up to this is unconformity. And up to which you are getting the subaerial signature. So river system and the pedogenesis, the wind erosion, the channel erosion, you are getting here. But this portion is subaqueous now. At 4, this portion is subaqueous. So its correlative conformity in the subaqueous part that we refer to as the correlative conformity. Am I clear? Is it clear?
Yes, sir.
Oh. Now we come on to river dominated, second case, river dominated coastline. In case of river dominated coastline, the entire thing is much higher gradient. Entire thing is much higher gradient, and the sediment supply is high. So always wave is subdued because it is a river dominated. River is carrying more sediment and it is not allowing the wave to play its own role. So what will happen that normally in a river dominated shoreline, as I discussed earlier also, the slope is about 1 degree, where in case of wave dominated 0.1 to 0.3 degree slope is, and it can go up to 30 degree in the Gilbert time. Gilbert time. 30 degree. So this high gradient, because of high sediment supply, that you are getting the unconformity to be formed in the shallow water, but you will not get any kind of wave erosion surface in the subaqueous. So forced regression in case of a delta, and there is a forced regression, that is happening, and the delta you are not supposed to get any subaqueous erosion surface which you will get in case of wave dominated surface setting. So it is not that the forced regression will always form the RSME. That is not true. RSME will be formed when you have a wave dominated surface setting. RSME will not be formed when you have a fluvial setting and the fluvial coastline with large amount of sediment supply. The wave is subdued. Wave cannot form its own equilibrium profile. Wave has no role. It is totally dominated by the sediment supply by the river, and that will not cause. So you will not. This will be all conformable succession that you will getting. No erosion surface that will be formed in case of the river dominated setting. Okay. Please draw it and then let me know. Is it done?
Yes, sir.
Okay. So, in outcrop, how I will be seeing the products of two things: normal regression and post regression. In both the cases, what I am saying that it is a wave dominated setting. Okay, not a river dominated setting. It is a wave dominated setting, but in one case there is a normal regression going on, in another case there is a post regression going on. So how the two things will be apparent to me, that I am seeing a product of post regression or I am seeing a product of normal regression. Okay. Now this is a normal regression. What is normal regression? In normal regression, that the rate of sediment supply, it always overrides the rate of accommodation generation. So the rise of base level, it is very slow and it cannot override the rate of sedimentation. So the rate of sedimentation will always be high. So the entire system is prograding. So rate of sedimentation is high. So the entire system is prograding and is becoming shallow, shallowing upward succession. And there will be a total gradation of the environment, right from outer shell, then inner shell, lower shore phase, middle shore phase, upper shore phase, post shore phase. So they are gradationally going shallowing up. So the entire succession, it will be a shallowing up to gradation, and what you are saying, the different environmental products and their mutual relationship all are gradational relationship, and there are erosion, also wave erosion, the storm minus Tonka erosion. So those are all environmental erosion, the autochthonous erosion that you will get, but you will not get any erosion because of the base level fall and the Eustacy or tectonics or climate related fall, which is outside the basin effect. That fall you will not get. You will all get the erosion surfaces which are belonging to the basin. So suppose there is a wave, there is a storm, and all these are basinal process. So no outside basin process and their related base level fall and its effect on the erosion, that I will not get in this case. But what will happen in the post regression? There is actually a base level fall. So what is happening? That your upper shore phase, post shore beach, this sediment that has come right onto the offshore shell, and thereby it has totally obliterated the middle shore phase, lower shore phase, and the inner shell. ये गायब ही हो गया. This is not present. ये गायब है. So all this कहाँ गायब हुआ? Because the port shore, the base level has fallen, and the port shore phase has advanced, and it has eroded. The RSME has eroded all these products. And erosionally, this will be overlying the offshore shelf. So that is the fundamental. So if here also on the offshore shelf, I am getting the shore phase product. Here also on the offshore shelf, I am getting the shore phase product. So the basic sedimentology. Whenever I am going to peel, I am seeing the product. How I am seeing the product? It is not that I am seeing a shore phase. How the shore phase is overlying on the shell? Is it gradationally overlying with all the intermediate environmental products, or it is obliterating some of the intermediate environmental products and the proximal product directly coming onto the distal product without the intermediate products in between and erosionally overlying the distal product? Then it is the post regressive. Am I clear? Aditi has said, mailed you the book of Catalogue. Have you all received it?
Yes, sir.
Achha. So, what till now what I have discussed the products of different system tracks. We have discussed the product of the transgressive system track, we have discussed the product of normal regression, we have discussed the product of forced regression. Even in the normal regression, we have discussed the difference in the product between the low stand normal regression and the high stand normal regression. All these things that we have discussed, and how these product of the different system tracks that they will be developing, and their difference between the wave dominated soul line and the river dominated soul line. All these things we have discussed. Now, if we think that there is a sinusoidal base level rise and fall, sinusoidal base level rise and fall, then what I expect that all these system track, they will be forming in a predictable manner. That we actually expect. If I start with a falling stage system track, it will be overlain by a low stand system track, that will be overlain by a transgressive system track, that will be overlain by a high stand system track. So that is a very predictable way, I expect, very predictable way, I expect that all the system track that will come one after another in the history, positional history of the basin. And if the basin is subjected to a sinusoidal base level rise and fall. Isn't it? That we expect it should be a predictable. So always there will be a forced regression that will be overlain by a low stand, that will be overlain by a high stand, that will be overlain by a TST, overlain by a high stand. So this is a predictable way of getting. But in nature, in many of the cases, we do not get it in a predictable. We do not get it in a predictable. We may see in one basin that only the forced regression low stand, again forced regression low stand, again forced regression low stand, no TST, no HST. I may also see in one basin that there is the normal regression transgression, again normal regression transgression, again normal regression transgression. No effect of forced regression of this. And this is very common from basin to basin, that we do not get all the system track in the predictable manner. Now, and this is I am telling you three different cases. How the three different cases that is not coming in the predictable. I am getting the forced regression low stand, forced regression low stand, forced regression low stand. Or I am getting normal regression, TST, NR, TST, NR, TST, NR, TST. Or I am getting TST, HST, TST, HST, TST, HST. Not getting that. All the possibilities are possible. Now, people say that how it happens, why it is happening that all the system tracks are not coming. Initially, people thought it is basically because of the erosional effect of the regression and transgression. Because erosion happens both in transgression as well as in regression. So all erosional effect that might have erased its preceding system track product. That is one of the possibilities, that the erosional effect of the transgression and regression that basically erased some of the products of the system tracks. But it is also possible that the sea level is not changing in a predictable manner. That is unpredictable rise and fall of the sea level. That the sinusoidal curve which we normally draw for a base level and the sea level, that is not always effective, and the sea level is changing in a very unpredictable manner. So what is happening? The other reason that people say that sediment starvation that can also change, sediment starvation that can also change the predictable character of the system. So what are the things I have said? Number one, the erosive effect of the transgression and regression which might have erased its preceding system track record. This is number one. Number two, that the sea level that may be more unpredictable way, the sea level, the base level is behaving. The base level change is not a very predictable matter. And number 3, that there is a sediment starvation, and that is not allowing some of the system track to be expressed properly. Sediment starvation, that the system track are not getting expressed properly. Suppose when you have a normal regression, transgression, normal regression, transgression, normal regression, transgression. What does it mean actually? The base level has never fallen. Base level always are rising, either slow rate or faster. So there is a variable rate of base level change. Sometimes the change of base level is slow, sometimes high. Sometimes again slow, high. So base level is always rising, never falling, and sometimes at a low rate, sometimes at a fast rate. So, and you are keeping the sediment supply constant. So if the sediment supply is constant and base level is increasing, sometimes at slow rate, sometimes at fast rate, so I will be only getting the normal regression and transgression, normal regression and transgression. Suppose I am getting the forced regression and normal regression, forced regression and normal regression, forced regression and normal regression. What does it mean? It means the base level either fallen or raised very slowly, but never the accommodation override the sediment supply. Never in the history of the basin field, the accommodation could overtake the rate of increase in accommodation could overtake the rate of sediment supply. And that is why I am never getting any expression of transgression. So if there is a forced regression, normal regression, forced regression, normal regression, that means that the rate of accommodation change never overtaken the rate of sediment supply in the basin. And that's why the signal of the transgression never came in my picture. Is it clear what I am saying? Why sometimes we are not getting the system track in a predictable manner? Hello? Hello?
Yes, sir.
So now I will just, you will be writing, I will be dictating something which in a very concise manner I will try to give you, because of many things I have discussed, and if you, Aditya sent the sequence stratigraphy book of catalog, and you are seeing that the entire sequence stratigraphy, you must have opened the book and seen that what vast the whole thing is that. So I understand that there will be problem. But just if you can listen to me clearly, I can dictate you the very of normal regression, transgression, and post regression. What are the criteria and how we basically that may help you? Okay, please write. You are listening to me now?
Yes, sir.
Okay. So first write that system strat. A basic definition of system strat. System strats are stratigraphic units bounded by sequence stratigraphic surfaces forming the subdivisions of sequences. This line definition is clear to you, na? Because all my discussion that system trap, they're bounded by system. We always, whenever I discuss any system trap, I said the lower boundary which surface and upper boundary which surface. So they are bounded by sequence stratigraphic surface, and they are subdivisions of a sequence. Subdivisions of a sequence. Okay. In self settings, comma, system tracks are directly associated with particular types of shoreline trajectory. Particular types of shoreline trajectory. You can write now. Problem तो नहीं हो रही है. हाँ. Including shoreline trajectory, including transgression, normal regression, and forced regression. Transgression, normal regression में ब्रैकेट में लिखो लो स्टैंड एंड हाई स्टैंड. And forced regression. Now we will write about transgressive systems. Transgressive system tracks, TST, are bound at its base by the MRS or the RS. And at the top by the MFS. And at the top by the MFS. Full stop. They are characterized by a retrogradational architecture If you find problem somewhere, please stop me and ask me. Characterized by a retrogradational architecture resulting from rates of accommodation creation rates of accommodation creation that outpace those of sediment supply at the shoreline. Sediment supply at the shoreline. Full stop. Full stop. A TST is typically accompanied by a deepening upward trend. is accompanied by a deepening upward trend in shallow marine settings. Deepening upward trend in shallow marine settings. Full stop. Next para. Next para. The relative thickness of TST deposit in a sequence may vary considerably because of accommodation to sediment supply ratio, comma, amplitude and shape of relative sea level curve, and position in the surface shelf system. Full stop. So this is actually the TST. Okay. It is bound at the base by MRS or RS and topped by the MFS. It is actually made by a retrogradational or deepening upward subsection. And in a sandstone shale alternate sequence, you will see that the shale is to sandstone ratio will be increasing upward. So that is, now you write the normal regressive system track. Within bracket low stand and high stand. Normal regressive system. Normal regressive system track deposit may be formed either between forced regressive deposit below and transgressive deposit above. Within bracket low stand normal.
So within bracket,
Low stand normal. Regressive. Low stand normal regressive. Or between bracket complete or between transgressive deposit below transgressive deposit below, and forced regressive deposit above. Forced regressive deposit above. Within bracket high stand normal regressive. Full stop. In other words, comma, normal regressive deposits may alternate either with transgressive strata, normal regressive deposits may alternate either with transgressive strata comma, in which case they are called HST, in which case they are called HST, or with forced regressive strata, or with forced regressive strata, comma, in which case they are called LST, which case they are called LST. Full stop. In revised Exxon model, the LST is referred as progradational to aggradational succession. Whereas HST is defined in terms of aggradational to progradational succession. Aggradational to progradational succession. First, depending on relative position, a normal regressive product can be, depending on position, a normal regressive product can be bound by different types of sequence stratigraphic cycles. A normal regressive product can be bound by different types of sequence stratigraphic cycles. Semicolon. Whereas a low stand normal regressive product is bound between correlative conformity and MRS. Correlative conformity and MRS at its base and top. Correlative conformity and MRS at its base and top. Comma. The high stand normal regressive deposit. The high stand normal regressive deposit is bound between maximum flooding surface MFS and BSFR at its base and top. Maximum flooding surface MFS and BSFR at its base and top.
Dr. BSFR, what is that?
MFS and the BSFR at its base and top. Next paragraph. Since normal regression is driven by sediment supply, since normal regression is driven by sediment supply, in shallow marine system, a normal regressive deposit gives a shallowing upward trend. A normal regressive deposit gives a shallowing upward trend.
So please repeat.
Since normal regression is driven by sediment supply, in a shallow marine system, the normal regressive deposit gives a shallowing upward trend. However, this trend may not be valid in relatively deeper part of the basin. I will explain that. अभी लिख लो, मैं बाद में explain करता हूँ. However, this trend may not be valid in deeper part of the basin. Full stop. A normal regressive strata is marked by progradation and aggradation. Progradation and aggradation. That allow accumulation of sedimentary bodies featured by clinoforms with aggregating top sets, featured by clinoforms with aggregating top sets. This I have already described and discussed.
So after aggregating,
Aggregating top sets. Then we will come to falling stage system trap, forced regressive deposit, falling stage system trap. The falling stage system trap consists of forced regressive deposits. And is bounded by the BSFR or the RSME at the base. And is bounded by the BSFR or RSME at the base. And by the BSFR and RSME at the base, and by the subaerial unconformity or correlative conformity at its top. Correlative conformity at its top. The FSST forms during relative sea level fall when the shoreline is forced to regress. When the shoreline is forced to regress, irrespective of sediment supply. Irrespective of sediment supply. In a low gradient wave dominated shoreline, in a low gradient wave dominated shoreline, low gradient wave dominated shoreline, forced regressive conditions typically result in formation of sharp base surface on the RSME, sharp base surface on the RSME, on top of RSME. Full stop. Next para. Forced regressive deposits are characterized by overlap, without offset development, due to the prevailing conditions of negative accommodation, In revised exon sequence model, the FSST is described as a degradational succession set. The FSST is described as degradational, D-E-G-R-A-D-A-T-I-O-N-A, degradational succession set. Okay, so this is what I thought of just giving you, because why I have here given you dictation. The reason is that there are large number of terms, and these terms they are related with the different system trap, and this what is the relevance of the term, which term is defining which system trap. This, you may be getting confused, so that's why I just given you a dictation that how the different system traps are. Now, two things what I have given you discussion also, and I believe that two things that need to be discussed also. One, as you see in the normal regression, it is said that in the shallower part, in the shallowing part, it shows a shallowing upward succession, but it may not be valid in the deeper part. May not be valid in the deeper part. What does it mean actually? Suppose I have a normal regression that is going on. The normal regression that is going on. Okay, normal regression that is going on. Now, what is normal regression? Your base level is slowly rising. Right? Now, when you have a base level slowly rising and your sediment supply more than rate of accommodation creation, but sediment supply is constant. Even if it is constant, it is always more than the rate of accommodation generation. Sediment supply is constant. Now, suppose the sediment supply is going on. Since you are basically prograding, so what will happen? Suppose this is there, then next is there. So the more you are prograding, you are going to the more deeper bathymetry of the ocean. Am I clear? Suppose what was the bathymetry here? This was the bathymetry. Next time bathymetry here, third bathymetry here, then bathymetry here. So the more you are advancing towards the basin, you are going to the more and more bathymetry of the basin. It is not the active accommodation generation. Active accommodation rate of base level high is not very high. So it is not adding the accommodation much. But you are actually proceeding to a deeper part of the basin. The basin has its own physiography, and the basin from here, the basin depth is here, and the basin depth is increasing. So what will happen? This sediment, which was enough to fill the accommodation here, it may not be enough to fill the accommodation here. Am I clear? Is it
Can you
clear?
repeat the last line?
Huh?
नहीं हुआ क्या?
Clear नहीं हुआ. On one hand, I am saying that the base rate of base level rise that is very slow. So this is the base level rise हो रहा है, and the rate is very slow. Rate is very slow. So the increase in accommodation or addition of accommodation is low. Accommodation is low. Now the sediment supply that is constant and it is more than the addition of accommodation. Sediment supply जो accommodation add हो रहा है उससे ज्यादा है. Fine. There is no
Excuse me,
problem.
sir.
Huh?
So we are discussing about normal regressive sequence.
Normal regression. So sediment supply, इसीलिए तो मैं बोला ना जो you just see what I have dictated in the normal regression. I have said that in the shallow marine part I will be getting a shallowing upward succession, but this case may not be valid in the deeper part of the basin. ये लिखा है कि नहीं?
Yes, I got confused that we are discussing right now about the transgressive sequence. It's all right.
No, I am talking about the normal regression.
Yes, sir.
Normal regression में ये line लिखा है ना?
Yes.
Yes. Why I have dictated that line? That I am expressing. Okay?
Yes, sir.
So sediment supply is constant and always more than the rate of accommodation rise. It is always more than, and that is why normal regression. But at the same time, during the normal regression, what you are getting aggregation and a progression. So because the sediment supply is high, so it is filling the accommodation generation and the more sediment that is spilling over to the deeper basin. So suppose I am generating this much space. Now the sediment supply, this is V1 and the sediment supply is V2. So V2 more than V1. So what will happen? The V1 will be filled and the extra sediment will be spilled over. That is exactly that the sediment what has been trapped here, that is trapped, and the rest that is the trapped sediment because of the rise of accommodation that is causing the aggradation, and the extra sediment that is spilled over which is causing the progression. It is clear till now?
Yes, sir.
Yes, sir.
Fine. Now, when you are doing the progression, successively you are actually moving to the deeper bathymetry of the basin. Initially this is the basin. So initially you have to fill this much space, then you have to fill this much space, then you have to fill this much space. So initially that spilled sediment that was sufficient to fill it. Then the spilled sediment is still sufficient to fill it. But after that, the sediment that may not be sufficient to fill it because you are going to the higher bathymetry as well. You are getting me? But the actual base level rise rate of accommodation creation by the base level rise is still very low. Still very low. But since you are actually advancing to the deeper part of the basin, you are struggling to fill the basin physiography and the available accommodation of the basin. It is not because of the base level rise, but it is because of the physiography of the basin. Am I clear?
So, sir, what kind of trend we will get in deeper?
Yes, this is what. Then what will get? So, जब initially तुम fill कर रहे थे, then you are getting a shallowing up pattern. Shallowing up जो मैं drawing भी किया होगा, succession कैसा होगा? Shallowing up pattern. But जब तुम you are struggling to fill, this has been referred to as a term by what they call the auto-transgression. Auto-transgression. This term has been coined by the Japanese worker Muto. He referred this as a auto transgression, where really no transgression. Base level has not yet started rising at a fast rate, but you are getting a transgressive signal because your supplied sediment is now struggling to fill the basin physiographic available accommodation, and that what he referred to as the auto transgression. You will start getting a transgressive signal without having a proper transgression. Am I clear?
Yes, sir.
This is what is referred as auto transgression, and that is why it is written in the deeper part, the shallowing upward trend may not be visible. You may see a so now problem is suppose when you have a normal regression, that normal regression is that of HS. Fine. Now, if this normal regression going on, you may get the transgression, but actually after HST normal regression, you get a falling stage system track. So you get a signal of base level fall. So होता क्या है? जब this normal regression do not happen for a long period of time. If you have a normal regression for a long period of time, it will generally lead to a transgressive signal. Long period, it will generally lead to a transgressive signal. But most of the cases, होता क्या है that it's a short period of normal regression is quickly gets succeeded by the active base level fall, and accommodation नीचे चला जाता है. So you get a erosion, HST के ऊपर FSST आ जाता है, or the base level started rising at a fast rate. So normal regression के ऊपर transgression आ. But if you allow normal regression for a long period of time, it itself will generate to the transgression. Am I clear what I am saying? It is a very tricky situation, extremely tricky situation. If you allow normal regression for a long period of time, it itself gives rise to the transgressive signal. But normally, normal regression do not operate for a long period of time, and a short period of normal regression is succeeded by the active base level fall or active base level rise. If active base level rise, then you get the low stand normal regression followed by transgressive system track. If active base level fall, then you get the high stand normal regression followed by the FSS. But if by normal regression it goes for a long period of time, then normal regression. So there are many cases, as I said, that there are successions where only the normal regression transgression, normal regression transgression, normal regression transgression. That is how the whole sequence is built up. So there, what is happening that never the base level is going down. You are actually the normal regression and वो अपने से transgression करा दे रहा है और base level is rising. Then you are और तुम्हारा माथा फोड़ना पड़ेगा ये actually the transgression is happening on normal regression leading to the transgression. Okay.
Yes, sir.
Yes, sir.
Okay. So I will end today's discussion in just with one more discussion. Class तो नहीं है अभी?
है सर 11:30 से.
किसकी क्लास है?
आशुतोष से.
Oh, so ठीक है. So let us stop this class now. We will discuss that in the next class. Okay. So some portion of the post regression रह गया that I will be discussing in the next class.
Okay, sir. Thank you, sir.
Thank you, sir.
Please
Thank you, sir.
any question in WhatsApp or if, because these are the not very easy things to comprehend or understand. So if you please read the academic book, if you find that there is something not getting clear, please ask me in the WhatsApp, or you can ask on mail or anything. Last time there is
Okay, sir.
okay.
Thank you, sir.
Thank you.